Problem 2. After finding 99999 all the way to what 2009 nines times 88888, which is 2009 eights, divided by 666, which is 2009 sixes, what is the digit sum of the number? Well, to find the digit sum of the number, we need to first simplify and find what is this number, right? So we have a lot of nines times a lot of eights and divided by a lot of sixes. Now, you might be asking me the question, why aren't you using the division symbol? Why are you writing it in fraction form? Why are you stacking them? And it's a good thing that you noticed, because the reason why I am writing it in fraction form is to make this simpler. I'm not going to write down and stack 2009s on 2008, 2009s on 2009 eights, multiply every single one of them, and divide that by 2009 sixes. That's not very efficient, as I would call it. The reason why I'm stacking it as a fraction is to simplify this fraction and make this a bit easier. So basically what I'm saying is, as a fraction, you can make division problems easier. You can make the number smaller, which means division would be easier for you. And I know I can do this also because they're all 2009s of something. So the number of 9s in here is the same as the number of 8s and is also the same as the number of 6s. Alright, so now you get the idea, and let's start simplifying. So what does this equal? Well, we're trying to get rid of this denominator of 6s. So to do that, we need to try to find a 6 from the top. But I don't see any. Well, let me first ask you, what is 6 equal to? Well, of course, there's 1 times 6. But it's also 2 times 3. And can we find a 2 from up here? And can we find a 3? Sure we can. We can split this 9 up into 3 times a lot of 3's times, and split this combination of 8's up into 2 times a lot of 4's, and divide that by the bunch of 6's. So now that we do that, we really see how we can first divide the 2 and the 3, of course. And out of these, we also have, so now we have lots of 1's over 3's times. Yeah, so we have 1's, so we still have a denominator. Let's see if we can keep simplifying that. Well, let's do the 4's, I guess. The 4's, after we do that, this would just become a 4. So it becomes the 2009 3's times 4. And now, let me make some more room. Now we have a lot of 2009 3's times 4. So what is a digit sum? But we can't just give up now. We need to calculate this. So what I'm going to do is I'm going to try 5 3's, let's see, instead of 2009 3's times 4. And I'm going to see what's the answer to this. So I'm gonna do that. Okay. So I get 4 3s, and at the very beginning, a 1 at the very end, a 2. So if I'm going to have 2009 threes, if I was going to have 2009 threes, I would get, if I had 2009 threes, I would get, in my answer multiplied with 4, I would get 1 3 3, a bunch of threes in the middle, and ends with 2. And in how many threes are there? There is going to be one less than 2009, which is 2008. So over here there are 2008 threes. So what is the digit sum of this number? We're going to add this. So we know that there's already a lot of threes, right? But 1 plus 2 gives us another pair of 3. So really we have 3 and 2009 pairs of it. So 3 times 2009 is 6027. So the digit sum of this number is 6027. Before we end this video, I want to have a quick conclusion. So first, what do? We thought about, well, should we write it in long division form? Decimal form? So there's division. But since the numbers are so big, I stacked them in fraction form. So we could simplify it. And after, it's just a lot of multiplication. And then we found the pattern using this. And we didn't go directly and try to solve the 2009 threes times 4. We first chose, well, what about 5 threes times 4? And we got 1, 3, 3, 3, 3, 2. And there were 4 threes, which is 1 less than the number of threes that started it off. So we apply that pattern to the actual problem we were trying to solve. And after thinking about the digit sums, which, see over here we had 2008 threes, but then there was another pair of 3, 2 and 1. So then we got 3 times 2009, which equals 6027, and that was our final answer. So thank you for watching, and see you in problem